I am Dr. Rajesh Rai. My dear students, we have already completed 2 modules in the operation research, first module and the fifth module. Now I am going to fourth module. In that fourth module, operation research subject, we are having 2 topics. One is network analysis, introduction of the network, construction of the networks, Fulkerson's rule for numbering the nodes, EON and EOA diagrams, critical path method to find the expected completion time of the project, determination of floats in the networks, part network, determining the probability of completing the project, predicting the completion time of the project, cost analysis in networks, crashing of networks and problems. Next part is queuing theory. Queuing theory, queuing systems and their characteristics. Queuing systems and their characteristics, pure birth and pure death models, equations, Kendall and Lee notations of queuing, empirical queuing models, numericals on single and C queuing models. Now let us go to the queuing models, queuing theory first. Now let us see the queuing theory. The queues are a part of everyday's life. We all wait in the queues to buy a movie ticket, to make the bank deposit, pay for groceries, mail a package, to get a train ticket, or obtain a food in a cafeteria, to have a ride in the amusement park, have become a man to wait but still get annoyed by the unusually long waits. Every people will get unhappy if you wait more than 1 hour or 2 hours. For that purpose, some of the queue models are developed. They are helpful in determining how to operate a queuing system in the most effective way. If too much service capacity is to operate the system and involves the excessive cost, the models enable finding an appropriate balance between the cost of service and the amount of waiting. Let us see the input is input source, queuing discipline, service mechanism and server. This is the queuing model. Now let us see what are the queuing models are there. Customer, population, it may be finite or infinite. Number of servers, it may be single or a multiple servers. Again in the multiple, finite or infinite. In the finite, series and parallel. Queue discipline. Queue discipline means first come first serve. In a queue, suppose you come first, you will get a first serve. Priority basis, sometimes we will get a service. Random, they will pick some person with the service. These are the queue disciplines. Arrival time and service time. There are distributions are there. Different types of distributions are Poisson distribution, constant distribution, general distribution or Erlang distribution. Now these are the things we will be going to see information required in the queuing this one. Elements of the queuing system. A queuing system can be interpreted completely by the following entities: the input or arrival pattern, the service mechanism or service pattern, the queuing process, the queue discipline, service channels These are the five things. The input. This indicates the pattern in which the potential customers arrive at the service facility. The customers arrive at the service facility individually or in batches separated by the equal intervals of time or by unequal, but definitely known intervals of time or by unequal intervals of time whose probabilities are known as random arrivals. Arrivals may also be presented by inter-arrival time, time period between two successive arrivals. In this queuing system, we deal with the customers arrive in Poisson distribution with the mean arrival rate A. Service mechanism or service pattern. This pattern indicates the manner in which the potential customers are serviced and leave the service facility. If enough service facility is available, then the customers are served simultaneously and effectively on arrival. There will be no queue. If there are finite number of service facilities, then the customers are served as per the specific order with the service time. The period between two success services. The service time could be a constant or random variable. In most of the cases, the departure follows exponential probability distribution. Queuing process. This refers to the number of queues. It may be single, multiple, or priority queues. If the service provider failed to accommodate the customers beyond the limit at a time, no customer is permitted to enter until the sufficient space is available to accommodate the new customers. Such queues are finite or limited source queues. If service facility is able to accommodate all the customers at a time, then it is called as infinite or unlimited source queue. Queuing discipline. This indicates sequence or order in which the customers from the queue are selected for the service. The most common disciplines are FCFS discipline, first come first served, in which customers are chosen for service in their order of arrival. LCFS discipline, last come first served, in which last arrived customer served first, as in case of cargo handling. C-row discipline, service in random order, where the customer is chosen for service at random, irrespective of their arrival of the system. Service channels. In order to serve the incoming customers, finite number of service facilities are arranged and are called service channels. The service channels may be arranged either in series or mixed arrangements. In series arrangements, number of service facilities are arranged in the sequence so that a customer processed through each facility ahead of the service is accomplished. In parallel arrangement, number of service facilities are in parallel so that customer can obtain from any service facility by joining the queue of their choice in front of the service facility. In mixed arrangement, number of service facilities are arranged in series as well as in the parallel. Characteristics of the queuing system. The following are the operating characteristics of the queuing system. Queue length, LQ, the average number of customers in the queue waiting to get service. System length, L, the average number of customers in the system, including those waiting as well as those being served. Waiting time in the queue, W, the average time for which the customer has to waiting the queue to get service. Total time in the system, the average total time spent by the customer in the system from the instant he arrives till he leaves the system. It is the summation of waiting time and the service time. Utilization factor. It is the proportion of the time a server actually spends with the customers. It is also called traffic intensity. Classification of queuing models. The queuing models are classified as follows. Model 1. This model deals with the queuing system having single server, Poisson arrival, exponential interval, Poisson departure, exponential service time on base of the first come first service discipline. In this, infinite number of customers are allowed in the system. Model 2. The general queuing model in which the arrival and service rates depend upon the length of the queue. 3rd, this model is essentially same as model 1st except that the service discipline is 0 random order instead of FCFS. Model 4, in this model the capacity system is limited to say n, hence the number arrival cannot exceed n. Model 5th, in this model probability of an arrival depends upon the number of potential customers available to enter the system. Model 6th, this model is same as the model except that there are service channels working in parallel. Kendall's notations. Classification of queuing model is using Kendall and Lee notations. Generally, any queuing models may be completely specified in the following symbolic form. A is the type of distribution of inter-arrival time, type of the distribution of inter-service time, number of servers. D is the capacity system. E is the queuing discipline. M is the arrival time follows Poisson distribution, service time follows an exponential distribution. This is the pattern how it can be specified. Pure birth and pure death process model. The pure birth process is one where the customers arrive at the queuing system and never leave it. In this model, only arrivals are counted and no departure takes place. The term birth refers to the arrival of the new entity in the system, the number of customers in the system at a time t before the start of the service facility. Pure death process per model is equal to the departure process assumes that no customer arrives in the system, while the service continued for the customers who are already in the system. While the service in the system at time t is equal to 0, let there be n is greater than 1 customers in the system time t 0, since service is being provided the rate process called as pure death process. Model 1st, single server, unlimited queue model, follows Poisson distribution with mean and variance equal to, it is given by formulas 1, utilization factor, traffic intensity, VGP rate, where lambda is the mean arrival rate, mu is the mean service rate. Note, service rate is greater than the in single server model only. Probability that exactly 0 units in the system